So in this video, we're going to have a look at writing total ionic equations. And then we're going to have a look at something else called net ionic equations. So we're starting with total ionic equations. The first thing that we're going to do is to write out our actual reaction. So we're going to do this example with a double displacement. Reaction. So the first compounds that I'm going to use is going to be sodium sulfide, and then I'm going to react that with iron 2 sulfate and produce my products. So with this double displacement reaction, our products are going to be sodium sulfate and iron 2 sulfide. So once I know what my reaction is, I want to write out the formulas for everything in my reaction. So my sodium sulfide formula is Na2S. Iron 2 sulfate is going to have a formula of FeSO4. And they're going to react to produce our sodium sulfate. And the formula there is Na2SO4. And then our iron 2 sulfide will end up being FeS. Okay. One of the other things that I want to do is to make sure that this reaction is balanced. So I just want to double check here. And it actually looks good. So we have 2 sodiums on either side. We have 1 iron on either side, 2 sulfurs on either side, and 4 oxygens. So it's an already balanced reaction. Okay, so when we're looking at ionic compounds, the one thing that we also want to review is what state each of these are going to be in. So we're going to look at our solubility table, and our sodium sulfide is going to be aqueous. It does dissolve in water. Our iron 2 sulfate also is aqueous. It dissolves in water. And then our sodium sulfate also is going to dissolve in water. Okay, so that's going to be aqueous. But the iron 2 sulfide is actually not aqueous. So it's going to be solid. It's insoluble in water. Okay, so what I want to do is I want to take apart my ionic compounds because I want to write them as they are actually going to appear in water. So I'm going to start with my sodium sulfide. So really this is 2 sodium ions that are aqueous and a sulfur ion that is aqueous. Okay. Then my iron 2 sulfate, because it dissolves in water, it'll come apart and form its ions. So that's really an Fe2+, that's aqueous, and an SO4 2-, that's also aqueous. And then I've got my reaction arrow, and my sodium sulfate is going to come apart in that same way. So I'm going to end up with 2 Na+ that are aqueous, and a sulfate. Got a 2- charge and is aqueous. But the last compound that we have here, the iron 2 sulfide, is a solid. So it's not going to dissolve in the water and form ions. It's going to stay as a solid. So we're going to keep that together. And so what we have here as this whole reaction, this is our total. So that whole reaction is our total ionic equation. Okay, so the reason it's called a total ionic equation is because we've got a reaction equation and it's showing all of the ions, right? So the total ions that are involved in this reaction. Now, you'll notice a couple of things. We have 2 sodium ions on the left here and 2 sodium ions on the right. And so those are actually what we call spectator ions. So spectator ions are things that don't change in the reaction. So on the left side of this reaction, we have 2 sodium plus, and on the right side, we still have 2 sodium plus. So they haven't changed throughout this reaction. We have another spectator ion in the sulfate. So we're SO42 minus. So same thing. Those are not changing throughout the reaction. They're ions on the left, they're ions on the right, and they haven't changed their formation. So what we're going to do is get rid of those spectator ions, and we're going to rewrite our equation showing everything that isn't the spectator ions. So our equation now looks like this. We've got S2 minus, that was aqueous, and an Fe2 plus, that was also aqueous. And now we're producing FeS, which is our solid. Okay, and now this reaction is called a net ionic equation. So again, it's a chemical equation. It's showing our ions, but instead of showing the total, we're showing the net value of the ions. So the idea is that we got rid of our spectator ions. So our net ionic equation has those spectator ions removed. And really, that's because those spectator ions are not changing as part of the reaction. So they're not necessary to write in the reaction. Okay. So let's try another example with writing a total ionic equation and a net ionic equation for another double displacement reaction. So another reaction we could use would be, so we're going to start out with a silver nitrate, and that's going to react with sodium chloride. And so then we're going to produce silver chloride and sodium nitrate in our double displacement reaction. So when we're ready to write our formulas, silver nitrate will be AgNO3. Sodium chloride we know is NaCl. Silver chloride, AgCl, and sodium nitrate, NaNO3. When we're going through our solubility table, we want to make sure we include whether we're going to be soluble or insoluble in water. And so silver nitrate, like all nitrates, is aqueous. Sodium chloride, we already know, dissolves in water. Silver chloride, though, happens to be insoluble. So is a solid, and then our sodium nitrate is going to be aqueous. And again, just a reminder, we're getting those states from our solubility table. Did our ionic compounds actually dissolve in water, or do they not dissolve in water? Okay. So when we're taking apart our ions, we're going to form silver with a 1 plus charge, that's aqueous, and then a nitrate with a 1 minus charge, that's also aqueous. From the sodium chloride, we're making an Na with a plus charge, that's aqueous, and a Cl with a 1 minus charge, that's also aqueous. The silver chloride is going to stay together. It's not going to form ions because it's not going to be dissolved in water. It won't dissolve in the water, it's going to stay as a solid. And then we're going to form our Na plus from our sodium nitrate, and then our NO3 with a 1 minus from our sodium nitrate. So then again, that is our total ionic equation. Okay, and when we're ready to write our net ionic equation, we just need to locate our spectator ions. So spectator ions are going to be sodium with a 1+ charge. Okay, it's on both sides of our reaction.